Well, the Internet protocol was specified in the RFC, in the request for comment number 791. In fact, those that kind of documents are the typical documents that are used in the Internet in order to specify the protocols and other kind of specifications that typically are used in the Internet. Then this is one of the most important standards of the Internet. The Internet protocol then is responsible for transporting data across multiple networks. When we talk about multiple networks, we talk about heterogeneous networks, that is local area networks, wide area networks from different technologies. Then, in fact, IP is encapsulated in the PDUs of all that kind of different technologies of the two lower layers of the OSI reference model. The Internet protocol, in fact, transmit messages, protocol data unit messages called datagrams, and those datagrams encapsulate, for instance, the segments of TCP and the datagrams of UDP. The Internet protocol provides an addressing mechanism that permit the identification of all the stations that in Internet we called hosts, and the identification of all the routers, that is the intermediate systems of the TCP/IP architecture. And finally, in order to could travel across different networks, different LAN and WAN networks with different MTUs, different maximum transfer units, the IP, the Internet protocol, must implement a function called fragmentation in order to permit the transmission across different links of different MTUs. Then remember the most important objective, goal of the Internet protocol at the Internet layer is the transporting data across multiple heterogeneous networks. That is, for instance, in this case, in this picture, in blue, you could see, for instance, a typical LAN frame, Ethernet frame, for instance, or in green, the typical WAN frames. Sometimes now in the WAN we use Ethernet frames too, but in fact this is a typical heterogeneous network using different LAN and WAN technologies in the lower layers of the architecture. The datagrams of the Internet protocol are encapsulated and decapsulated and re-encapsulated in the different PDUs of the lower layers. And this is the mechanism that permits the interconnection of heterogeneous networks. The Internet protocol then allows the interconnection of heterogeneous networks through an appropriate addressing, global addressing scheme, and a particular mechanism of routing those messages called datagrams, and that algorithm is called destination address-based routing. And the third main function of the IP protocol is the fragmentation and reassembly. Then we will talk about those three functions during this lecture and the next lectures. Remember, the global addressing scheme, the destination address-based routing, and the fragmentation and reassembly mechanism. Then the first important terminology and concept is the use of the internet addresses that for instance, in the version 4 of IP is a number of 32 bits, that is 4 octets or 4 bytes. Instead of specify this number in binary or in decimal, typically we use a notation called dotted decimal notation, where each byte or each octet is represented in decimal notation, and each decimal number of each octet or byte is separated by a colon, a dot. Excuse me, not a colon, a dot. And then this is a typical example of dotted decimal notation for an IP version 4 address. What is important then to know is every IP interface of a host or a router must have an IP address assigned. In this case, for instance, those are hosts with an IP address assigned to its interface, and those are routers. Each router has at least one interface one IP address per interface, and perhaps one of those interfaces, if those interfaces are point-to-point interfaces, where only two endpoints could exchange packets or datagrams, we could use in this case a particular configuration called IP and number. That is, interface is configured is IP active, but without without a particular IP address associated, but is in fact an exception in the configuration of the TCP/IP networks. The packet switching refers to the, in fact, the mechanism of receive the datagrams or packets over an interface and forward that packet or that datagram over another interface. In this case, that is in the case of the Internet protocol, the Internet protocol functions as a connectionless protocol. That is, nothing is remembered in those routers, in those intermediate systems, about the previous traffic. Then only we remember which are the routes in order to reach destination, and then that information is stored in a particular table called the routing, the IP routing table. The datagrams could be transmitted from one end system to the other end system, following that is those datagrams could be forwarded from, for instance, this router to this router, and after that the final destination. But they could in fact travel across a different path of the network. And then the difference between a circuit switching and the packet switching network is the messages, the datagrams, the packets that need to travel from, for instance, A to D could travel across a different path. In this case, for instance, the packet travel from A to X, from X to Y, and finally from Y to D. But in this case, this packet travel from the A node or A host to the X router, from the X router to the Z router, from the Z router to the Y router, and finally from the Y router to the D host. The IP routing then is performed using an algorithm called destination address based routing. That is, IP datagrams are forwarding based on the destination address of the datagram. Then we use in each host or router a table, a routing table, and the routing table at each row of that routing table, in fact, is called a route. Then each route indicates by which interface each destination is reached, and also indicates if it's a route, a direct route, that is a route that permits to reach the destination directly, or an indirect route. In the case of indirect routes, the route need to specify not only the interface by which we could reach the destination, but the next hop, that is the IP address of the router that we need to which we need to send the datagram in order to reach the final destination. And if in this route no route match the destination address of the datagram, the IP entity of the host or the router drop the datagram. Remember that this behavior is very important because this is the behavior that avoid the occurrence of the loops that we already seen in the LAN switching technology. This is an important aspect to notice, to remark. Not only the routers has an IP routing table. Not only the routers has an IP routing table. The hosts have an IP routing table too, and that is important because the routing table, for instance, in this case, for instance, the routing table permit to identify which is the interface and which is the next hop to reach each possible destination. But in this case, for instance, the routing table differentiate at least two routes. The local route, that is the direct route in order to reach destination in this local area network, and for instance, at least one direct route, typically, for instance, a default route to reach, for instance, across this network, and using this IP address as the next hub in order to reach any other destination that is not reachable locally. Well, this is the structure of the IP version 4 packet. And then, in fact, this is in fact the header of the datagram packet, or the datagram, the IP datagram, or the IP packet. After these options, these possible options, we have the payload of the datagram, the IP datagram or IP packet. The words, the datagram use typically words of 32 bits. That's why, for instance, here you are the source address of 32 bits, the destination address of 32 bits. Those are two very important fields in the header of the IP datagram. This is another very important field, the protocol. This is the protocol number identify the protocol that is encapsulated within the payload of the datagram. Or for instance, well, the version, in this case, the version will indicate the number 4 for IP version 4. Or for instance, the total length of the datagram. And if you pay attention, the total length has 16 bits. Then the total length of a datagram could be a maximum of 65,512 bits. Bytes. The length is specified in bytes. That is more or less 64K bytes. This is an important concept. Then that is why this is an important concept, because the payload of the datagram could allocate a maximum of 64K bytes. And then the maximum segment, TCP segment, will be of 64K bytes, or the maximum UDP datagram could be of 64K bytes. And other fields and other important fields, for instance, are those one, the identification, the fragment offset, and the more fragment bit, or for instance, the don't fragment bit, that are used in the fragmentation mechanism. Finally, for instance, the time to live is a number of 8 bits that indicate how many hops the datagram is able to pass, and each time that the datagram is forwarded, for instance, in router, the router decrement this number. When this number arrives to 0, the router or the host that decrement this number, and this number is finally 0, indicate that the datagram must be dropped. Well, perhaps one of the other fields that I didn't mention, but perhaps are important. First, for instance, the internet header length of 4 bits indicates how long is the datagram header, but specified in words of 32 bits. Then, for instance, we could have 15 words of 32 bits. That is 15 words of 4 bytes. That is 60 bytes, the maximum. In fact, we could see that the header has typically, without options, the header has typically 1, 2, 3, 4, 5 words of 32 bits, that is 5 words of 4 bytes, that is 20 bytes, 20 octets. The header, the typical header of the internet has 20 octets or 20 bytes. Finally, for instance, I could talk about this field, the type of service now called the DSCP, the Differentiated Services Call Point, and is used, in fact, to tag the data line with the quality of service that is required by the application that is encapsulated into this data gram.